Hello, my name is IP Kukenesi and my metric number is CF190015. I'm going to present about the introduction of this project report. The stability of a slope is always discussed in the terms of its susceptibility to failure and is a topic of serious concern to geologists all over the world. Slope stability defined as the resistance of any inclined surface as the wall of an open pit or cut to failure by sliding or collapsing. Any ground surface that stands at an angle to the horizontal is termed an unrestrained slope and can be of natural origin or man-made. As the ground surface is not horizontal, there will always be the tangential component of gravity that tends to move the slope-forming materials downslope. If the tangential component of gravity is very large and the internal shear strength of the slope-forming materials rather low, a slope failure can occur. Both natural and man-made slopes can be stable or unstable, and several methods of analysis of their stability have evolved from simple to more sophisticated ones. There are various classifications of slope failures, but the most useful classifications are those that employ as their primary criteria the type of movement and the type of slope forming materials evolved with secondary considerations of velocity and the amount and phase of water. There are simplest methods of classifications where six types of failures are recognized: falls, topples, slides, lateral spreads, flows, and complex.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zuhabi Jabri, F190020. I would like to continue the next presentation. My part is about literature review. Alright, the overview of this literature review. This chapter consists of three major parts, which are: the first one is technique of slope stability remediation. The second one is risk management strategy for slope stability, and the last one is theory for slope stability analysis. Alright, the first part is technique of slope stability remediation. This technique have three major parts. The first is geometrical method, the second is drainage methods, and the last is retaining structure method. For the first method is geometrical method. It's slightly reducing the steepness of a slope can make it safer for people to traverse. Next is slope trimming or reducing additional weight from the slope can be employed to implement this strategy. Next is backfilling is also covered in this group. And the last is this method is easy and affordable. The next method is drainage method. This strategy is effective if the surface and subsurface drainage system are properly maintained, and it is possible to reduce the wetness of the subsoil by designing the drainage system for the surface layers, hence increasing the stability of the slope. And the last method is retaining structure. This technique is pricey, but it is extremely versatile, and the retaining structure are utilized to overcome the pushing forces of the soil masses. The third one is contiguous board piles, gravity, and cantilever retaining wall. And soil nailing are just a few examples of the many retaining structures that can be used to keep slope stable. Fourth, retaining structures include, but are not limited to, gravity walls, cantilever walls, contiguous board piles, coincidence, steel sheet piles, groove punchers, and soil nails. And the last is in remedial work. This is often the most common strategy. As a result, a confident structure is needed to sustain and restabilize the failed slope in these project's boundaries. Alright, next we go to the risk management strategy for slope stability. We have four parts. The first part is risk-based planning of slopes. The second part is risk management framework. And the third part is probability of slope failure. And lastly, the fourth part is risk management and consequence estimation of slope failure. And then it's about a theory for slope stability analysis. We have three parts. The first part is Bishop method of slides, and second part is Kuhlman's methods, and the last is ordinary method of slides. Alright, we go to the first part. The first is about Bishop method of slides. As opposite to a traditional slicing method, stresses rather than force are used to examine the structure. In contrast to the ordinary method of slides, this method resolves details vertically rather than horizontal, making it unique using Bishop's method of slices. Safety factors are very similar to those calculated using more rigorous approaches. The next is human method. If you are looking for a sliding surface, planus isn't the best option because it can only be found on extremely steep incline. And the last but not least, the ordinary method of slides. When the effective angle of shearing resistance is not constant, zoned earth dams where the failure surface may pass through a range of different materials are explored. That's all for me. Thank you.
Techniques of slope stability based on case given. First, retaining wall. This procedure is often more expensive than the previous one, but because of its adaptability in a confined environment, it is always the most widely used method. The underlying premise of this technology is to create a retaining structure to withstand the downward forces exerted by the soil mass itself. As shown in the figure, gravity types of retaining walls, cantilever walls, contiguous board piles, caisson, and steel sheet piles are among the retaining structures that can be constructed if the driving forces are too great to be resisted by the retaining structures. Ground anchors or other tie-back system may be utilized in the conjunction with them. Next is tie-back wall. For a long time, tensile reinforcing components and flexible retaining walls have been used in conjunction with one another. The usage of rebar ties with channel wallers, also known as belt beams, in conjunction with a mechanically stabilized embankment of narrow proportions. It is necessary to utilize these walls when the area is confined in a space or when thin retaining walls are required. When dealing with loose soil on rocks, anchored retaining or tie-back walls are the best option. It's necessary to install deep cable rods or wiring routes that run horizontally into the dirt before filling the end with concrete to serve as anchors. Next is drainage method. The best choice of techniques to remedial the slope failure is hydrological techniques, which is drainage method. Saturation and poor water pressure to build up in the subsoil are two elements that cause slope failure. If a drainage system had been installed, the risk of poor water pressure building up and subsoil saturation would have been reduced. This approach has the potential to be incredibly successful. However, in order to function successfully, the drainage system must be maintained. Surface drains are simple to keep in a good working order, while subsurface drains are most complicated. Weep holes techniques and cut-off drain are the most common subsoil drains seen in retaining structures. Surface drainage systems are simple to implement and provide excellent slope protection. As a result, they should be regarded as one of the first measures to avoid possible stability issues. Subsurface drainage is equally significant in cuts and embankments, and the most subsurface drainage remedies may be used in both scenarios to avoid and repair landslides. Landslides may occur when embankments are built on potentially unstable slope because the embankment increased shear pressure surpass the foundation soil's shearing strength. If the embankment obstruct the natural flow, groundwater instability may ensue. As a result, two aspects must be addressed when investigating potential instability, such as weak zones in the foundation that may be overstressed by the planned embankment load and the increase in pore water pressure sufficient to induce the considerable drop in the soil shear strength.
Hi, my name is Nur Emila Fazli Zaidi, metric number AF190011. Next for our application is for first geometrical method, one of the most common method that used in residential area. This method simple and use less cost. The changing of the angle from the steep slope to a gentler slope may increase the stabilization of slope angle, usually supported by grass bonding together with soil. Residential area were built on wide area to facilitate construction of remedial work. This method not required heavy load resistance and naturally stabilize the slope with the creepy grass surface. And then for the next is drainage method. One of the slope failure factor is saturation and poor water pressure building up in the subsoil. The changes of building up poor water pressure and saturation of subsoil can be managed if the drainage system has been provided. Subsoil drain is mostly found in the retaining structure as with hole method and cut-off drain. This method usually combined with other methods, and then surface drain mostly used in geometrical method, while the subsoil drain is part of the method combined with retaining structure. And then for the retaining structure, this method generally most costly and then most commonly adopted method due to its flexibility. And the principle of this method is used to retaining structure to resist the downward forces of the soil mass. And then the retaining structure include gravity type of retaining wall, cantilever wall, contiguous board piles, caisson and steel sheet piles. This method also rigid slope surface protection such as shotcrete, masonry and stone pitching.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Maad Sadaq Hassan Ali. My metric number is BF19008. In this video, I will speak about my part, which is long-term stability for the chosen technique. The chosen technique is the drainage method. Drainage technique of water is an effective method of increasing the stability of slope. Water is in a slope may come from the primary sources, surface water and groundwater. Water control is generally maintained through installation of surface and subsurface drainage devices within and adjacent to potentially unstable slopes. There are two types of drainage system: the surface drainage system and subsurface drainage system. Surface drains and landscape design are used to direct water away from the head and two of cut slopes and potential landslides and to reduce infiltration. Subsurface drainage system: the main function of subdrains are to remove subsurface water directly from unstable slope to redirect adjacent groundwater sources away from the subject property and to reduce hydrostatic pressure beneath and adjacent to engineered structure. For most slopes with heavy flowing water, horizontal drains are cost-effective, visually appealing, and typically low-maintenance option to reduce poor pressure and promote stability. They can be built in a rock slope. They are excellent for large-scale slope instability with possible sliding plans, 26 feet deep inside the rock block, because unbroken rock stores very little water. The most important concern in constructing horizontal drains is to position the holes such that they traverse the greatest amount of the water carrying fractures. We choose drainage because of the drainage system, its high stabilization efficiency in relation to design and construction costs. Drainage of surface water and groundwater is the most widely used and generally the most successful slope stabilization method of all possible schemes to be considered for the correction of exciting or potential landslides. Proper drainage is probably the single most important. Drainage will both reduce the weight of the mass tending to cause the landslides and increase the strength of the material in the slope. A reduction of the actuating forces. A slope is a limit of equilibrium when the actuating forces balance the resisting force. In this case, the factor of safety, the slope is equal to unity. The actuating forces can be reduced and hence the factor safety increased by improving drainage or by reducing the weight of the material potentially involved in the landsliding. The following techniques are suggested for the study area. Number 1, improved surface drainage, and number 2, improved subsurface drainage. Improved surface drainage at all roadside landslides. The shire has used the technique with some success for a number of roadside landslides. Number 2, improved subsurface drainage. Subsurface drainage is often the most effective means of removing excess groundwater. It is usually expensive to install but would be worth considering for selected landslide in the study area. Various drainage systems can be used. Number 1, narrow trench drains filled with gravel legend directly downslope. Sub-horizontal drains. Number 2, sub-horizontal drains. Number 3, galleries and vertical drains. And thank you.
Conclusion. In conclusion, it is concluded that the slope conditions in this area are considered less stable due to its weak geological structure conditions, such as a high topographic areas, large slope, and high discontinuity content. The high amount of rainwater infiltrating into the soil weakens the soil structure and causes an active weathering process that produces sandy soils. A high percentage of cavity space increases the level of soil porosity, further increasing the infiltration rate. Low aggregate stability due to low organic matter result in a lack of water retention level in the soil. Meanwhile, the rate of water content in the soil also affects the hydraulic velocity of its conductivity. High rainfall intensity resulting in increased groundwater content as a result of rapid infiltration. Through various investigation, it is clear that the landslides are triggered by several factors. However, their chances can be minimized by employing a risk management strategy to cope with the factors causing slope instability and to take appropriate remedial measures for the recertification. The benefit of adhering to a risk-based strategy is that it identifies the vulnerability to slope as a result of various factors by locating the risk and evaluating its intensity, which leads to the selection of a proper mitigation technique and reduction in the chances of slope failure. To curtail the landslide events, this paper suggests that use of drainage system method as the solution for the prevention of landslides. Thank you.